Alright, this is a question on combined circuit, and this is slightly more difficult, but it's doable. Right, the first part of it, it says calculate the effective resistance of the circuit. As you can see, this circuit is made out of a parallel circuit and also followed by a resistor by the side. The voltmeter does not come into play because what we are interested in are the resistors. Okay, so over here you can see there's a parallel circuit, and next to it is a single resistor, and this is what we call a series. Okay, so this is basically a combination of parallel and series. Okay, so how do we find the effective resistance? So the first part is you have to find the effective resistance of these three that are in parallel. So you can actually use this formula, 1 over 10 plus 1 over 20 plus 1 over 10, the whole thing will inverse. And since this whole thing is in series with the 6 ohm, so what I do is that I add this to 6. Okay, I don't add 6 into the bracket 1 over 6 because the 6 is not part of the parallel circuit. Okay, so if I were to calculate it, and the answer would be 10 ohms. Okay, what is the reading of the A meter? So over here they are asking us what is the current of the circuit. So again, remember, part B is linked to part A. So okay, this student did not write the formula. So the formula is actually I equals to V over R. So we are using back the same old formula, Ohm's law. Okay, in fact, we are just using one single formula, which is Ohm's law. Right, the voltage is basically 12, which is shown here at by the battery, and the resistance, we are taking the total effective resistance which we have calculated in A. Okay, because we are trying to find the total current, and it will give me 1.2 ampere. So over here I can actually label it as 1.2 ampere. Okay, what's the reading of the voltmeter? So be careful, where is the voltmeter placed? The voltmeter is placed here. Okay, so what is the voltage of this particular 6 ohm resistor? So I use back the same formula, V equals to R times I. The resistor will be 6 and the current will be 1.2. Okay, what I get is 7.2 volts. So in the diagram I can actually write this as 7.2 volts. Okay, so the next question is, what is the potential difference across the 20 ohm resistor? Where's 20 ohm resistor? It can be found here. So the difficult part is, okay, I know that this is 7.2 volts, but what is the voltage of this 20 ohm? Alright, and I know that this is actually a parallel circuit. So all the resistor within the parallel circuit would have the same voltage, okay, because this is one of the rule for parallel circuit. And I know that the total voltage is 12 volts. So how do I know what is the voltage, okay, of this parallel circuit, which will enable me to find the voltage of the 20 ohm resistor? Okay, so this is quite simple because as you can see, we have found 7.2 volts and the total voltage is 12 volts. So this is in series with this. So what I need to do is just to take 12 volts minus 7.2 volts, and I'm able to find the voltage, okay, of the parallel circuit. So 12 minus 7.2, what I will get here is 4.8 volts. And 20 ohm is part of the parallel circuit, and therefore the voltage of the 20 ohm resistor will be also 4.8 volts. Alright, the last part of it, determine the current through each branch of the parallel circuit. Alright, so as you can see, be careful of this, and it's 3 marks. Each branch meaning that, okay, where are the branches? And where is the parallel circuit? Okay, the parallel circuit is found over here. So firstly, there's one branch, there's the second branch, and this one is the third branch. So how do I find all 3 current? So same thing, alright, what we are using is basically I equals to V over R. Okay, so to find the first branch I1, I need to take the voltage which I found over here, 4.8, divided by the resistance, which is 10, okay, and I can get 0.48 ampere. The second one, same thing, the voltage is 4.8 because in the parallel circuit the voltage will be the same for all three resistors, and okay, and the resistor is actually 20. Okay, so this student actually wrote, so this one should be I2, and this one should be I3. So 4.8 divided by 20 will give me 0.24 ampere, and the last one will be the same as the first one. Okay, it will be 0.48 ampere.